In this lesson, we're going to be looking at some of the main measures that are used in statistics, measures of center and variation. The measures of center that we're going to be looking at are mean, median, and mode. The measures of variation we will be looking at are range and standard deviation. Alright, so when we're finding the mean, we're just finding the average of that set of values. Population mean is symbolized using mu, lowercase mu. Sample mean is used, the symbol we use for sample mean is X bar. For the population size, capital N, sample size, lowercase n. Both of these are calculated by adding all the values in the group and then dividing by the number of values. Median means the middle. The median is determined by arranging the values in order, from least to greatest or greatest to least, and selecting the middle number. Now, note that if there are an even number of numbers, then there will be two middle numbers. And the way that we find the median, if there are an even number of numbers, or we add the two middle numbers together and divide by 2. Mode is the number that occurs most frequently in the data set. And if there's no repeating numbers, then we say that there's no mode. If say there's 2 2s and 2 3s, two numbers that occur most frequently, we say it's bimodal. If there's 3 numbers that occur most frequently, then trimodal and so forth. The range gives us how values vary, or the span of the values. The range is determined by subtracting the smallest number in the data set from the biggest number. And the formula that we use to find the standard deviation, it varies slightly depending on if we're taking or finding the standard deviation of the population or the sample. The symbol that's used for population standard deviation is a lowercase sigma. The symbol used for sample standard deviation is a lowercase s. For population standard deviation, it's the square root of each one of the values in the data set minus the mean of the data set, the mean of the population mu. So we're going to subtract the mean from each one of the values in the population. We're going to square each one of those differences, add them all up, and then we're going to divide that quantity by n, the population size. Take the square root of that. Similarly, to find the sample standard deviation, we're going to subtract the sample mean, X bar, from each one of the values in the sample. Square all of those differences, add up all of those squares, and then divide by 1 less than the sample size. Take the square root of that value. Alright, so in this example we've got 6 numbers in the data set. X bar and mu, the population and the sample mean and the population mean, they're going to be calculated the same way. It's the sum of all the values divided by the number of values, which is 87. Now to find the median, we need to arrange the values in order. And we have an even number of numbers, so there's going to be 2 middle numbers. So the median is going to be the average of those 2 middle numbers. 88 plus 90 divided by 2, which is 89. And the mode is the number that occurs most frequently, which is 90. Alright, same set of values. The range is going to be the biggest number minus the smallest number. The biggest number in the set is 93. The smallest number is 78. 93 minus 78 is 15. And these are the formulas we're going to be using to find the population and sample standard deviation. Alright, so for the population and sample standard deviation, we're going to have to subtract the mean from each one of the values in the data set. The population and sample mean, they're both 87. So we're going to subtract 87 from each value in the data set. We get the following numbers. Then we're going to square each one of those differences. We square each one of those differences. We get 9, 36, 81, 1, 9, and 16. Add up all those squares, and we get 152. Alright, so 152 is going to be used in both formulas. So for the population standard deviation, it would be the square root of 152 over 6, which is approximately 5.03. Sample standard deviation would be the square root of 152 over 5, which is 1 less than the sample size. So if those set of values represented a sample, it would be 6 minus 1, which is 5. Square root of 152 over 5 is approximately 5.51.